All right, my favorite part. My favorite part is all these word problems that I know you love. Now listen, there's one thing you have to understand about word problems. There looks like there's a whole mess of them, but truly they only fit in about 3 or 4 different categories. The first category that we're going to go over is direct translation, where we don't have to do much, we just look at the words. Okay? I know you're not going to like what I'm going to say here, but the biggest problem that people have with word problems is the reading, not really the math. Because once we set it up, you all can do it. So the first thing we're going to do is read this. Then we're going to underline all the keywords that we talked about in the previous lessons, and then we're going to set it up. So here we go. The difference between a number and 2, comma, that's important, divided by 3 yields twice the number less 4. Now we're going to read it a little slower. Difference is a big keyword. The difference between a number and, well, we're going to talk about, this is not really a keyword, but it's an important word. Okay, so we're going to underline it. Between a number and 2, okay, divided, still important, comma's important, by 3, oh, look at all of this, yields, big time keyword, twice the number, less 4. Oh my gosh, look at all of this. Okay, let's start with the difference between a number and 2. Okay, difference means to subtract. If you remember the last time we talked about this, the and tells me where to put that operation sign. So there's where your minus goes. The difference between a number and 2, comma. That means that whole thing is divided by 3. Okay, not just a 2, but that comma tells me, think of that as one thing, and that whole thing is divided by 3. Okay, yields, remember, means equals twice the number, 2 times the number, less means subtraction, 4. Now it's not less than would switch the order. It is actually less, so we put it just like that. Now we're going to solve this problem. Okay, remember this is really a fractional equation because there's my fraction. I'm going to clear the fraction, which means I'm going to multiply every single side in every term, that means, by the LCD, which is 3. So I'm going to multiply this by 3. And by multiplying this whole side, if you remember, it means that I'm actually going to multiply each term by 3, because I'm really distributing that 3. And I get x minus 2 equals 6x minus 12. Keep solving. Subtract 6x, subtract 6x. We get negative 5x minus 2 equals negative 12. Okay, so now I'll rewrite that up here so we can see it. And we get negative 5x minus 2 equals negative 12. Get all the variables to one side, they already are, all the numbers to the other, so I'll add 2. Negative 5x equals negative 10. Divide by negative 5, and of course this is old news to you, x equals 2. Okay, now to make sure we're right, we really should check in the words. So I'm going to do that. We have x equals 2. Let's check that and make sure it follows all the words. Just because we got a nice clean answer doesn't mean it really works. So let's see. Do not check in the equation you wrote because you wrote it. You could have made a mistake. You got to check it in the words. And I think we talked about that in previous lessons. Okay, the difference between a number and 2, well, our number is 2, okay? So here's our check. The difference between a number, which is the 2, and 2, that's 0. That's got to be divided by 3. So that's got to be divided by 3. Remember what happens when you divide 0 by any number? You get 0. Remember, here's the check. 0 times 3 is 0. Okay, so divided by 3 yields, that's supposed to be equal to twice the number less 4. So let's do twice the number is 2 less 4, and this is 0. So it does yield that. So that is the answer. So that's not our answer, that is our check. Our answer is x equals 2 for this problem. That's a great problem. All right, we're going to see some more problems just like that. All right, here we go. Here's another one, direct translation. I'm going to do this first one for you, okay, and then from start to finish, then I'm going to ask you just to set up the equation that you would use to solve number 2. Okay, so let's look at number 1. Find the number And I'm no longer going to underline the actual numbers like 5, 8, 2/5, okay? Find a number of 2/5 of, this is a keyword, of the number is, and here's the other keyword. Okay, so let's talk about what of and is mean. Okay, of means to multiply, is means equal, okay, or is equal to. Find the number if 2/5, so 2/5 of, that means times, multiply, the number is 4/5. That's how easy that one is, which is just, you don't need that little dot there, 2/5 x equals 4/5. There's a number of ways to solve this. We learned proportions in a couple lessons ago. We could do that, or we could just treat this as any fractional equation whose LCD is 5, and we can multiply this side by 5 and this side by 5. That makes this nice and easy, because now we can reduce, and we get 2x equals 4, dividing by 2, we get x equals 2. X equals 2 seems to be a very common answer. So we get x equals 2. That's the answer to this question. And now we're going to check it. Okay, so remember the answer is 2. Okay, so remember we got x equals 2. So now we're going to check that in the words. Remember, we cannot check it in the equation that we wrote, because we wrote it. We could have made a mistake. So here we go. Find the number. We already did x equal 2. If 2/5 of the number, so we're going to do 2/5 of the number times the number. Since this is a fraction, we're going to make the 2 into a fraction, writing 2 over 1, and that's supposed to be equal to 4/5. Well, clearly that is, because 2 times 2 is 4, 5 times 1 is 5. So 4/5 equals 4/5, and there it checks out. So that's how you do that problem. I'd like to take a second and talk about this problem a little bit, and if you would read this, underline or box in your keywords and just set up the equation to solve this problem. And then when you're ready, click on the video and we'll begin. Okay, if 3 times the sum, oh, now this is an interesting one. 3 times, so we have times as a keyword. I'm going to use a little different color so that maybe you can see this a little better. The sum of the number, and that's not a keyword, but it's an important word, okay, is a keyword. Decrease by is important. Twice is important. The result is, here's your keyword, okay, -6. So let's take a look at this a little bit. All right, 3 times the sum. If you recall when we did this before, 3 times the sum. It's an operation followed by an operation, so we're going to use a parentheses. 3 times the sum of the number and 4. So here's how this looks. I know you might have written, not probably, but might have written that. That's not 3 times the sum. That's 3 times a number increased by 4, or the sum of 3 times a number and 4. So we want 3 times the entire sum. So an operation followed by an operation, we need to use parentheses, if you remember that. Okay, so that takes care of that, just that part. Okay, 3 times the sum of the number and 4 is, that's not the is for equals. Sorry, look at that, I almost got caught there. Here's the equals, okay, because is decreased by twice. So that's decreased by twice the number. Oh, it almost got me. The result is, there's your equals, -6. So this is decreased by, which is that minus, okay? Be very careful there. It almost got me. But here's the equals. The result is, okay? So had I looked for that equals first, I probably wouldn't have made that error. Okay, so let's take a look at this. And now we're going to have to distribute. 3x plus 12 minus 2x equals -6. All right, that's beautiful. Now before we move, remember, we're going to combine like terms. Here we can combine. 3x minus 2x is just x, and that equals -6. All our variables on our left get our numbers to the right, so we'll subtract 12, x equals -18. So we get -18. We want to make sure we're correct. To make sure we're correct, we're going to have to check this. So I'm going to erase this and put the check right here. Okay, we're going to check x equals -18. Let's see what we got. 3 times the sum of a number and 4. So we have to do the number and 4, the sum of the number and 4, which is negative 14. Now we have to do 3 times that sum, okay, which is negative 42. That's 3 times the sum of a number and 4, okay, and that's supposed to be decreased by twice the number. We have to decrease that by twice the number. Wow, and that number is negative 18. So this is negative 42 plus, because a negative times a negative is a positive, 2 times 18 is 36. This gives us negative 6. That's supposed to be the same. Oh, I'm sorry, the number and 6. The result is negative 6. That's supposed to be negative 6, and there you go. So that is negative 6. So we're done, and that all checks out. So it really might be a good idea to look for that is first and read everything before it, put that into symbols, then the other side of the equals. Okay, so you don't get a little screwed up here just because this is an is. This is not an equals is, that's is decreased by, tells me to subtract. So that's it for that problem. We'll try another one. All right, number 3. I'd like you to go to the workbook and just set up the equation for this. Do not solve it, because if you set up the wrong equation, we're going to spend a lot of time erasing. So just set up the equation you use for this, and then click back to the video, and we'll continue. Okay, find a number if the sum, so there's a keyword, right? The sum times is a keyword of 3 times the number, and not a keyword but an important word, is 4 less, okay, is 4 less than, oh, less than biggie keyword. We'll talk about that, and let's talk about why that's got an asterisk, okay? If you remember, less than or the word from actually switch the order. So I'm going to read until I get to this equal, because this is an equal, so let's read until we get there. The sum of 3 times the number and 10. So here we go. The sum, that means we're going to add 3 times the number, and that tells me where to put the plus. So 3 times the number and 10 is 4 less than the number. Well, this whole 4 less than the number, we have to switch the order. So whatever comes after the word less than goes first, the number goes first, and then whatever's before the less than goes second. So there we go. Okay, 4 less than a number. This is 4 less than the number. Now we're going to solve this. It's pretty easy. We're going to subtract x or subtract 1x under its like term. So we get 2x plus 10 equals negative 4. Again, all the variables are on the left, so let's get all the numbers to the right. So subtract 10, 2x equals negative 14. Divide by 2. Divide by 2. Remember, we get x equals negative 7. So we get negative 7. Again, we have to make sure that's right, so we're going to check that. I'll forget what the answer is if I don't do that. Okay, the sum of 3 times the number, so 3 times the number, and 10, so we're going to have to add 10, that's negative 11, okay, is 4 less than a number. That's supposed to be 4 less than a number. So let's go back to the number, and this is supposed to be 4 less than that. Well, 4 less than that is negative 11, so that checks out, okay? So we know we did that right. Okay, so now we're going to look at 2 other problems, all right? So let's look at them, 4 and 5. All right, this is number 4. What I'd really just like you to do in number 4 is just, again, do the equation, and we'll come back, hit the video, and we'll come back, and we'll give you a chance to solve it yourself also. So hit the video when you're ready. All right, again, let's look at some keywords. Find a number if 2/3 is added to 3 times. Okay, so added to or added, there's a key. 3 times, there's a key. And not a key, but important, the result is, there's our equals, right? There's our equals. 1/2 subtracted from, really important, ding, 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 right? That changes the order. Twice the number. Another important word, twice. Twice meaning 2 times. So I'm going to read exactly before the equals, and then we'll start from there. 2/3 is added to 3 times a number, and the result is 1/2 subtracted from twice the number. Okay, so here we go. 2/3 is added. 2/3 is added to 3 times a number. Okay, and the result is, this add is not telling me where to put my plus because this added to already did. Okay, it's just telling me what else is happening. And the result is, there's my equals, 1/2 subtracted from twice the number. Now be careful, remember subtracted from switches the order, so I can't put 1/2 down, I have to put what comes after it. So it's twice the number that comes after it. 2x minus 1/2. If you're not sure why this is the correct interpretation of this, then ask the teacher in the room. But this is how this should be set up, and why don't you take a second to solve it, and then click back on the video when you're ready. Okay, when I look at this, I see a fractional equation whose LCD is 6, 2/3 and 1/2. I'm going to multiply both sides by 6. Remember, if I do that, what that really means, it means I'm going to distribute the 6 because these are terms. So this gets multiplied by 6, this gets multiplied by 6, this term, and also this term. So each term gets multiplied by 6. Okay, remember, it keeps that equation in balance. Okay, so here we go. 3 goes into 3 once, 3 goes into 6 twice, 2 goes into 2 once, 2 goes into 6 3 times. Kind of pretty. Now our fractions are gone. 2 times 2 is 4, plus 18x equals 12x minus 3. Now, this is your call if you want to move the numbers or the letters. I like to move the variables first. So I'm just going to subtract 12x, and we get 4 plus 6x equals negative 3. Again, all the variables are on the left, so get all your numbers to the right. So subtract 4, and we get 6x, getting pretty low on this board. 6x equals negative 7. Oh no, it's going to be an ugly answer. It's okay, don't think you're wrong. We divide by 6, x equals negative 7, 6. That is my answer. So don't go crazy, oh my God, I got a fraction. That's okay, it doesn't mean you're wrong. We're going to check this for you in a second, but so far it appears that your answer is negative 7, 6. So let's make sure we got this right. Okay, to check this, remember we cannot substitute it in here because you wrote this and this may be wrong, so let's substitute it into the words of the problem. All right, remember we just got negative 7, 6 because you didn't like that answer? Let's check it out. 2/3 is added to 3 times the number. So we're going to add 2/3 to 3 times this number. Okay, and that's how I'm going to set it up, just because 2/3 is added to 3 times this number. This is a fraction, so I wrote this as a fraction. Let's see what we got here. Let's hope for the best, huh? So we get 2/3. A positive times a negative is a negative. That's 7/2. Okay, now we need a common denominator. Common denominator is 6. So I think the check is harder than the problem. We have to multiply that by 2, so we have to multiply the top by 2. Remember, whatever we do to the bottom, we must do to the top because we're multiplying the entire fraction by 1. And we get 4/6. Here we do the same thing, but we have to multiply by 3/3, that form of 1. And we get 21/6. And now I keep the denominator, 6. 4 minus 21 is a negative, because I have 4, I owe 21, so I owe more than I have, so that's a negative 17/6. Now, it says, and the result is, okay, that result is 1/2 subtracted from twice the number. So let's do 1/2 subtracted from twice the number. So we have to do twice the number, and we have to subtract 1/2. If that comes out to be negative 17/6, we are correct. Drum roll. Okay, I'm only kidding. All right. 2 goes into 2 once, 2 goes into 6 3 times. That's negative 7/3 minus 1/2. We need a common denominator. Again, it's 6. We have to multiply this by 2. So that's negative 14/6 because that's a negative. We have to multiply this by 3. That's 3/6. I owe 14, I owe 3, take the sign with the number. I owe 14, I owe 3, so I owe 17, keep the denominator. And yes, that checks out. So our answer was correct, no matter how ugly it got. Okay, we'll take a look at the next problem in a minute. All right, so look at this one. This one looks like it's full of fractions, your favorite thing, okay? Take a second to go to your workbook and put this in words, in symbols. and do not solve it, and then we'll come back and we'll look at it together. Okay. Find a number if the quotient of 3 times a number in 12 is added to 3 halves and the result is 3/4. Well, here's your is, right? Here's your result is, there's your equal sign. Let's take care of that right away. Okay, now, quotient, there's a biggie, of 3 times a number, 3 times a number, and there's a keyword, 12 is added to, or just added to is your key there. Okay, so here we go. Find a number if the quotient, there's division, of 3 times a number, 3x, here comes a division, and, okay, quotient is going to be followed with the and. The quotient, the product, the sum, the difference, they're all going to have an and in there to tell me where to put that symbol. That's my division symbol. I don't write this thing anymore. That's not for algebra so much. We want that line, okay? So the quotient of 3 times a number and 12 is added to 3 halves, and the result is 3/4. That's beauty. That's a beauty. If you didn't get this and you're not sure why, ask the instructor in the room. Okay? But now we're going to solve this. So remember, this is a fractional equation. I don't like to work with fractions. I like to clear them. Okay? I think that's good. With all the problems we do, it makes them easier. So my LCD is 12, okay, for all the fractions. So let's multiply each fraction by 12. Okay. And then 2 goes into 2 ones, 2 goes into 12 6, 4 goes into 4 ones, 4 goes into 12 3 times. Now our fractions are gone. We're going to have an equivalent equation. So 3x times 1 is 3x. 6 times 3 is 18. 3 times 3 is 9. Beautiful. Now we're going to solve this. We're going to subtract 18, subtract 18. 3x equals -9. Divide by 3. Divide by 3. X equals -3. So the number we have is -3. Okay. Now, of course, what do we have to do now? Yep, we have to check this problem. So in a second, we'll check it. All right, we got -3 for this problem. Let's check it. And again, I write this for myself because I'll forget what the answer is already. The quotient of 3 times the number, so 3 times the number and 12, okay, that's supposed to be added to 3 halves. And we're supposed to get 3/4. So let's pray for the best here. This is -9/12 plus 3 halves. Now, this is actually up to you. You can work with this and use a common denominator of 12, or you can reduce this fraction. I like to reduce the fraction, but that's absolutely up to you. So I'm going to reduce this fraction. I'm going to divide the top and the bottom by 3. So 9 divided by 3 is 3, or -9 divided by 3 is -3. 12 divided by 3 is 4. I mean, I just like to use a smaller fraction, but that's up to you. So here's what I have so far. I have -3/4 plus 3 halves. Okay, and now we need a common denominator. Our common denominator is 4. I'm going to have to multiply this by 2 to get me that 4, so I have to multiply this by 2, and that's 6. I owe you $3, but I have $6, so I owe you $3. So -3/4, and sorry. See? Thought I got it wrong, but I didn't. Because if I owe you 3 and I have 6, that means I have 3. So there's your 3/4. That's why I check. All right, so that's it. We're good. Our answer is -3. Great problem. All right, we're going to go to a really cool problem next. This was direct translation. Now we're going to come, because we took every problem, direct translation, because we took every word and just kind of put it into symbols. Now we're going to do something a little different. All right. I know I said the other ones were my favorite, but these are truly my favorite, because these are the real problems that you're going to get in real life. Nobody's going to come up to you and say, oh, if 3 times a number added to 4 is 12, what's the number, or I'll shoot you. Nobody's going to say that. They're going to come up with some everyday problems that you're going to have to solve, more like a story problem. So let's take a look at this. The owner of a small cafe found one day that the number of orders for tea was 1/3 the number of orders for coffee. If the total number of orders for the 2 drinks was 76, how many orders was placed for coffee? All right, let's take a look at a closer look at this. You want to follow some steps, which is on the key information in your workbook. The first thing is to make a key. This is extremely important. The key is a key for your unknowns. You know, they have this on maps. You know, on a map it might say, 1 inch equals 5 miles, and we've done this before. So let's take a look at this. The owner of a small cafe found that one day the orders for tea was 130 orders for coffee. So the unknowns are tea and coffee. So that's how we're going to start. So number of orders for tea, number of orders for coffee. Okay, when we do this, I'm going to make X, and of course there's different ways to do this, but I'm going to make X the one we have no direct information about. And then the other one is going to be an expression in X. Don't make somebody X and somebody Y. Make sure it's the same variable, and I like X. Some people like N, I like X. But you know that from lessons ago. Okay, so the owner of a small cafe found that one day, here we go, the number of orders for tea, here's the important part, number of orders for tea was 1/3 the number of orders for coffee. Okay, they gave me direct information about tea. They did not give me direct information about coffee. We can assume or tell you what we know about coffee, but they didn't give me any direct information about coffee. It says number of orders for tea was blank. So they told me about tea. They didn't say anything about coffee, okay, or any direct information about coffee, so I'm going to make that X. Now it says, I'm going to reread it. Once I do that, I reread that sentence. The number of orders for tea was 1/3 the number of orders for coffee. So tea is 1/3 of coffee. Even though it doesn't say of coffee, it does mean 1/3 of the number of orders for coffee. So this is 1/3 of means to multiply coffee. That's your key. That's what you have to do in step 1 and step 1, okay, and 2. That's my step 1 and 2 on the key information. Step 1 on the key information says make a key, okay, and then step 2 tells you how to make the key. So for me, this is step 1 and 2. Now for step 3. Step 3 is write down any information you know. Well, here's what I know. In words, I know that tea plus coffee. And when I say that, I really mean the number of orders for tea and the number of orders for coffee equals 76. That's what I know. Okay, so that's my step 3. And step 4, I'm going to write an equation. Okay, so here we go. T is 1/3 x plus x. Where am I getting this? Right from the key. T is 1/3 x. Coffee is x, and that equals 76. Okay. All right, actually, this is, in my key information, this was that actually 3? I'm just trying to get exactly right in words, okay? Write an equation. So the equation is step 4, so that's right. Okay, my step 5 is to solve the equation, of course. To me, this is a fractional equation. I know I can do this easily. I don't really want to. I like to clear the fraction. So this is my step 5. I'm going to solve the problem, or solve the equation. I'm going to multiply everything by 3 to keep my equation in balance. And remember, we've done this before. So good night. This is x plus 3x equals 76 times 3 is 228. Let's make sure I did that right. 18 carried a 1. Yep, that looks good to me. X plus 3x is 4x, which is 228. Divide by 4. Divide by 4. X equals 57. Now, and this is our step 5, which was the solution. Once we solve it, we have to plug the answer back into the key to get both our variables. And I want to talk a little bit about that. So this 57 represents not x. I mean, yes, it represents x, but to me that's meaningless. It represents the orders for coffee. So there's 57 orders of coffee. That's what I know. Now, I know that you could subtract 57 from 76 to get your T, but you should not. And here's why you should not. If you do that, you're not going to find an error, because if this was wrong, then the T orders are going to be wrong. So the only way to find your error is to go back to the key and do it. So now I want 1/3 of 57. And if you remember anything from some of our previous lessons, we know 57 is divisible by 3 because 7 plus 5 is 12, and 12 is divisible by 3. Remember that old trick? That was kind of cool. Okay, so we got 1 carry to 2, we get 19. So there's 19 orders for t. If we did this right, it will solve all the words of the problem. Well, so let's see. Okay, the number of orders for tea was 1/3 for coffee. Well, we already made sure of this. This is 1/3 of that. We already just did that. So that we know is fulfilled. The total is 76. Well, let's see. 57 plus 19. So here, and I hate to tuck it away like this, but here is my check. 57 plus 19 is 76. We already knew this part checked out is 1/3. There's the second part of my check. So it all checks out. So the number of orders for coffee is 57. The number of orders for tea is 19. So step 5 was to solve it. Step 6 was to plug it in and get our answers. And step 7 was to check it. So there's steps 1 through 7. Okay? Let's take a look at some other problems. All right, we got these 2 problems coming up. The basketball game is number 1 in your workbook if you look at it, and it's also on the slide in front of you. And Joelle is 4 years old, older than her sister. We have that slide coming up. What I'd like you to do is just to make sure you understand the whole key thing is to just set up the key. Do not solve them. Do not write up the equation. Just set up the key for number 1 and number 2. And when you're ready to move along, then just hit the video. Okay, let's look at number 1. In a professional basketball game, the winning team won by 7 points. So you got 2 teams going on. You got the winning team and obviously the losing team, because somebody has to lose, right? And this is the key. This is what we need to have. Okay, the winning team won by 7 points. So we know something directly about the winning team. We know they won by 7 points. So we don't really know anything directly about the losing team. Okay? Though of course we can assume we know they lost by 7 points, but we don't want to go there. Just go directly from the words. We know that they won by 7 points. So they have 7 more points than the losing team. That should be your key for that problem. Okay? So as we take a look at this, what I'd like to do now, right after this, is just to set up the problem a little bit, okay? Okay, so what else do we know? Well, we know, and remember, this was really step 1 and 2 because we had to get both variables. Now we're going to write down what we know in words. Well, we know the winners plus the losers equals, I think they said they scored a total of 201 points. Was there no defense? Anyway, okay, so we know the winning team plus the losing team is 201. Okay, so the winning team is x plus 7, the losing team is x, and that equals 201. And this was step 4 in our key information, to actually set up the equation. Step 5, if you recall, was to solve the equation. So we have 1x and 1x, or 2x plus 7 equals 201. We're subtracting 7 to solve this. 2x equals 201 minus 7 is, I forgot what that is. Okay, is 201 minus 7, 193. Nope. Let's try that again. 194. We just learned how to count. Okay, 194. Divide by 2, divide by 2. X equals 2 and 19 goes 9 times. Carry to 1. 97 points. What does that represent? That's X, but X is the losing team. The losing team scored 97 points. Okay. And the winning team was 97 plus 7, or 104 points. So we got 97 for the losers, 104 for the winners. Okay. And we wanted to know how much did each team score, and here you have it. But we have to make sure it follows the words of the problem, which is that this is 7 more than this, which it is, and also that this adds up to be, so here's the check, this adds up to be that 201, okay? And there it is. So there's your check. So once you get the key, that really tells me the whole thing, because once I have my key, I then write out what else I know, set up the equation, and solving, always go back to the key. So that's it. In a second, we'll do that question about Joelle. So let's make sure your key is correct for that one. All right, let's go to Joelle. I think a minute ago I talked about Joelle and her sister. Sorry, it was her husband, but who cares? All right, so here's number 2. It says, Joelle is 4 years older than her husband. So these are the two unknowns. The sum of the ages of their ages is 118, and find the age of each of them. Okay, so we have Joelle. When I say Joelle, I really mean Joelle's age and her husband. Her husband's age. This is the key. This is step 1. This is problem number 2. I should probably get that off there so you're not confused. Problem number 2, step 1. Okay, there's the key. It says, Joelle is 4 years older than her husband. So it tells us something specifically about her, Joelle. She's 4 years older than her husband. So we're going to make her husband X, but Joelle is 4 years older than him. So Joelle is X plus 4 or 4 plus X, whatever you like. So that's actually step 2 and 3. Okay, step 4 is to write what else we know in words. Well, we know that Joelle plus her husband is 118. Wow. Okay. So here we go. We'll plug it in. Step 5. Plug in what we know. Joelle is X plus 4. Her husband is X years old. And that equals 118. Okay. Solving this, we get 2x plus 4 equals 118. Subtract 4, subtract 4. 2x equals 114. Still solving. Divided by 2. 57. So we know x is 57, but what is x? X is her husband's age. So her husband is 57 years old. And we know Joelle is 57 plus 4, which is 61 years old. And now we have to make sure it just matches the words. Okay, so here's the check, and we can actually do this check in our head if we'd like. First of all, we need to know Joelle is 4 years older than her husband, and she is. We also have to know that these two add up to 118. And if you want to see that check, you can. You can't see it directly, but here it is. So it checks out. So there's Joelle. All right, let's get these are way too easy. Let's get to something a little harder. Okay, this next problem is about J.J. Hernandez, and he's building a cabinet. I would like you to read this, take a look at your workbook, read it, and just write down how you think this problem is different from the other ones we just did, the 3 other ones we just did. Okay? And then click back to the video when you're ready. Okay, let's take a look. J.J. Hernandez is building a cabinet. The instructions require 3 pieces of shelving. The longest piece must be twice the length of the middle piece, and the shortest piece must be 10 inches less than the middle-sized piece. He has a piece of shelving that's 70 inches long. How long will each of the 3 pieces be if she cuts from the 70-inch piece? I guess she's a she. Sorry, not a he. Okay, so here's the deal. The deal is that if you looked at the first types of problems we did way earlier, they were just direct translation. Then you saw the one we did with the basketball and with the cafe, and I think the last one was with Joelle and her husband, and they were all 2 unknowns. This is the first one we have and have ever done that are 3 unknowns. And you know what I'm going to say, right? My favorite. Okay, so let's take a look at, one more time, what the variables are. Okay, J.J. Hernandez building a cabinet. There are 3 pieces of shelving, the longest piece, the middle piece, and the shortest piece. So this is what we got. This is the key. We got the shortest, the mediumest. All right, I'll just say, no, I like mediumest. I like it to keep going. And the longest piece, that's what we got. Okay, now here's the deal. Here's how this is going to work. And if you look in your workbook, there is a key of things to do, key information for things to do. The first thing is we have to make the key just like before, but we have to read the problem and we have to make x the, here's what's going to happen. We have to make x the one we know nothing about of the first 2 variables they mention. So if we go back to the problem and read it, it says, J.J. Hernandez is building a cabinet. That's nice, but who cares? The instruction requires 3 pieces of shelving. Nice, who cares? Okay, here we go. The longest piece must be twice the middle. Stop. Stop reading. The longest is twice the middle, because they're talking about 2 there. Stop reading. They have not said anything about the shortest yet. Do not make X the shortest piece. Make X the one you know nothing about of the 2 they just mentioned. So the longest piece must be twice the middle. So they mentioned the longest in the middle. X is going to be one of those. The one they don't give you any direct information about. So here we go. The longest piece is twice the middle. Okay. Longest piece is, so they're telling us something about the longest. It's twice the middle. Nothing about the middle. So longest piece is twice the middle. So the longest piece is twice the middle. Okay? Now, let's look at the next sentence. Now keep reading. Okay? And the shortest piece is 10 inches less than the middle. Okay, I'm just going to write that for a minute. Shortest is 10 less than middle piece. Middle or medium piece, whatever you want to call it. Okay, now look, here's the key phrase we need. This is the, the big key, because this means we're switching the order. The shortest is 10 less than the middle. So the middle piece has to go first. The middle piece is X. Less than switches the order, but it means subtraction. So there's your shortest piece. Now here's what's really cool about this. Remember the blank we just had? This is what we just had. We wanted information about the shortest piece to finish this key, and we have it. It's right there. It gave us information directly about that shortest piece. That's really awesome, because if it didn't, we'd have to do something else. Okay, so we have X minus 10. So now our key is ready. Okay, now we do what we did before. We write down in words what we know about these 3 pieces, or any other information we know. Let's see what we know. It says, he has a piece of shelving 70 inches long. Okay, so let's think about this for a second. Let me just grab something over here for 1 second. Okay. Let's suggest this is his piece of shelving. All right, it's this long. You can't really see it. Okay. Okay, that's the length of the total shelving. Well, this is the smallest piece, the medium piece, and the longest piece. What we know are all 3 pieces, the short plus the medium plus the longest, must add up to that 70 inches, because that's what we want to put together. We want to put that all together, and I didn't take this apart on purpose because I need to show you something else later, but the shortest plus the medium plus the longest has to be 70. So now I set up my problem. The shortest is X minus 10 plus the medium, which is X, plus the longest, which is 2X, which equals 70. Now we solve it. 2, 3, 4 X's minus 10 equals 70. We add 10. 4x equals 80. Divide by 4. X equals 20 inches. Now, once I have that, go back to your key. 2 times 20. 40 inches. 20 is my X. 20 minus 10, which is 10 inches. If we did this right, yes, it adds up to 70, but that's not enough. That's not enough, because you could still do this wrong and it adds up to 70 if you don't check all the words. So let's check all the words one more time. Okay, the longest piece is twice the middle. The longest is twice the middle. That checks. Okay, and the shortest is 10 less than the middle. The shortest is 10 less than the middle. That adds up. Now it solves every part of it, and now we're done. The shortest is 10 inches long, the medium is 20 inches long, and the longest is 40 inches long, and that solves that problem. This is my favorite type, well, almost my favorite, because there's one more, there's another. So, but let's talk about what we have so far. We have direct translation, if we go word for word, underlining the keywords. We have 2 unknowns, and now we have 3 unknowns. What's going to happen next? Okay. All right, this one's for you. We have this question about Rosie, Jill, and Maria, and they're saving money to throw their parents an anniversary party. Okay, so what I'd like you to do before we start this problem together is create the key, set up the equation. Do not solve the equation. Try to do that. Let's see how far you get, all right? All right, because you know what? We're just going to check it anyway. Click the video when you're ready. All right, here we go. Rosie, Joe, and Maria were saving their money to throw their parents' 25th anniversary party. That's nice, but not important. Rosie has $150 less than Joe. Maria has 2 times the sum of what Joe and Rosie have, and they have served a total of blah, blah, so much money. Okay, so we have 3 unknowns. Here's our key. We have Rosie, Joe, Maria. Now remember the deal with the key for the 3 unknowns. The first sentence, or somewhere in the first sentence, when they start talking about the variables, they're going to talk about only 2 of them. We're going to stop reading right there, okay? So I'll scream stop. All right, here we go. The party, here we go. Rosie has $150 less than Joe. Stop reading. Rosie has $150 less than Joe. So I don't directly have any information about Joe, so he's getting the X. Rosie has $150 less than Joe. Now watch this. Rosie has $150 less than Joe. Something should be going on in your head. Boom, 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 right here, here. Less than, switch the order. 150 less than Joe. So Joe's going to come first. Joe is X. So that's what Rosie has. X minus 150. Okay, so that's how we got that. So you get the X by the first time they start talking to variables. Of the 2 they talk about, the one they don't give you any direct information about, then you read it again, get the second one, then you read on to get Maria. Now here's the deal. If we are lucky, the next sentence will talk about Maria. It will say Maria whatever, blank. Okay, if it doesn't, we have to write it so it does. So watch this. We don't. This is easy. It says Maria has 2 times the sum of what Joe and Rosie has. So she has 2 times the sum. An operation followed by an operation. So she has 2 times the sum. So I need a parentheses. Operation 2 times the sum. Times and sum. Operation followed by an operation, need a parentheses. And she wants the sum of the other 2. There's the sum of Rosie and Joe. Rosie plus Joe. Rosie plus Joe. This I can reduce a little, or simplify a little. X plus X is 2X minus 150. So that's what that is. Okay. So if you did that, that's awesome, because that was a little tough. Okay, now we're going to set this up. What we also know is we know Rosie plus Joe plus Maria has saved up $3,426. All right, so here we go. Rosie is X minus 150 plus Joe, who's X, plus Maria, who's 2 times the quantity, 2X minus 150. And that equals 3,426. Now we're going to simplify this. Distribute. 2 times 2X is 4X. Positive 2 times a negative 150 is a negative 300. As I say that and write a 1. That was clever, huh? Equals 3,426. Now 4X, 5X, 6X's. Done with the X's. I owe you 300. I owe you 150, so I owe you 450. And that equals 3,426. Ready? Still with me? Here we go. Add 450. Add 450. And we get 6X equals 6. That's 7. That's 8. 3876. Now, do you remember this rule to know you're divisible by 6? I'll remind you. To know you're divisible by 6, you have to be divisible by both 2 and by 3. So how do I know I'm divisible by 2? The last digit is even, so I am. How do I know I'm divisible by, say that quick, divisible by 3? You add up the digits, and if the sum is divisible by 3, then your number is. So let's see. 6 plus 7 is 13. 13 plus 8 is 21, plus 3 is 24. That's divisible by 3, so this number is divisible by 2 and by 3, therefore it's divisible by 6. That was fun, wasn't it? That was fun for me. Okay, let's divide by 6. Let's divide by 6. X equals 6 into 38 goes 6 times, remainder of 2. 6 into 27 goes 4 times, remainder of 3. 6 into 36 goes exactly 6 times. So X is $646. Well, who is X? Come over here. X is Joe. Joe has saved up $646. $646. $646. And now here we have 646 minus 150, which is 646 minus 150. 9, 496. And here, oh, x is 646. It's going to be a little annoying, but we can do it. 2 times 646 is 12. That's 9. That's 1292 minus 150. That's 2 times. Ready? That's 2. That's 4. That's 1. 1142 multiplied by 2. 2284. I hope I did that right in my head. Okay, let's check it out. If we did it right, it will solve all the parts of the problem. Okay, we're going to check this in a minute. All right, here comes the check, guys. Let's hope we're right. Here we go. Let's hope we didn't make a silly mistake. First thing we want to know is Rosie has 150 less than Joe. Does Rosie have 150 less than Joe? Yes, because if I add 150 to this, I get this. So that's right. Maria has 2 times of the sum of what they have. Well, I'm going to check this a little bit because that's a little too hard to do in my head. Okay, Maria has 2 times the sum. So the sum is 646 and 496, right? That's 12. That's 1142. And Maria does have 2 times that sum because that sum is 2 times that sum is 2284. So that checks out. And the very last thing is that together they have saved $3,426. Here's the rest of the check. So we have 646 for Rosie, 496 for Joe, which we already know since we already did that. That's 1142. We already did that. Plus what Maria had, which is 2284. $3,426. Is that what we wanted? Yes, that's what we want. Home run. All right, so Rosie, 496. Joe, 646. Maria, 2. Oh, this is unfair. Maria's spending all the dough. Anyway, that's the end of that problem. Let's look at one more problem in this lesson. Oh, 2 more. I think we have 2 more. Okay, let's go to the next one as soon as we're ready. An 84-foot log is cut into 3 pieces. So the second piece is 5 times as long as the first piece. Listen to this. And the first piece is 7 feet less than the third piece. So there are 3 pieces. So we have 3 unknowns again for this problem. Now, here's the problem with this. We have 3 unknowns, but let's set them up. We have the first piece, the second piece, and the third piece. You're probably wondering why I'm not sending you the workbook, huh? There must be something different about this problem. Let's see if we can figure it out. So here's the key. The key is the key to all these verbal problems. Anytime there's more than one unknown, we want a key. Okay, so here we go. An 84-foot log. That seems to be very tough for me to say. An 84-foot log is cut into 3 pieces. Okay, let's pretend this is the log. Okay, and it's cut into 3 pieces. Okay, I'm going to cut it in a minute. But anyway, so that the second piece is 5 times the first. Okay, stop reading. There's the 2 pieces. Second piece is 5 times the first. It tells me nothing about the third. Don't worry about it. But as far as the 2 pieces, the second and the first, it says second is 5 times the first. So it doesn't tell me anything directly about this first piece. So that's X. Now let's go read that again. Okay, the second piece is 5 times the first. 5 times the first. Now, if we are lucky, the next statement will start with the third piece. If not, we're going to rewrite it so it does. Here's the deal. This is not the only way to do this problem, but it's the easiest way for me to explain to you how to do these problems. So let's look at the next sentence. It says, and the first piece is the next sentence, and the first piece is 7 feet less than a third. First piece is 7 feet less than the third. Okay, here's the problem with that. The problem with that is I don't care about the first piece, I care about the third piece. So I'm going to rewrite this in terms of the third piece. This is common sense. If the first piece is 7 feet less than the third piece, how could I write a sentence that starts with the third piece? Well, if the first piece is 7 less than the third, then the third piece must be 7 more than the first. Right? The first piece is 7 less than the third, then the third must be 7 more than the first. Why did I do that? Because the third piece is what I have a blank for. I need to write in something about the third piece. It's 7 more than the first. Not the only way to do this problem, just my option. I'm taking this option. Okay, so that's the key. If you don't understand how we did that, ask the instructor in the room. Okay, now, we need to write down what else we know. Remember what we knew? We had this 84-foot log. Here it is. It's cut into 3 pieces. Now, hold it. Before I cut this into 3 pieces, I want to make sure you understand this. Right now, it's this long. Yes, this is 84 feet. Okay, in my world, but I'm only 2 feet tall. Okay, so I'm going to cut this. Oh, I just lost the magnet. That's not good. I'll have to show it to you. Okay, I'm going to cut it. It worked better at home, guys. Oh, I lost the whole magnet. Oh, I got it. Okay, so I got this piece. There's the first piece. It may not be the true first piece, but there's a piece. All right, I swear this will cut. Okay, maybe it won't cut. But here's almost 2 pieces. And if I put them alongside each other, what do you know about the 3 pieces together? They're still the same size. They're still 84 feet tall. So it doesn't matter if we cut them. What matters is the fact that they add up to that same 84 foot. And that was horrible, but I did my best. So I know the first plus the second plus the third was 84 feet. Okay, so here we go. That's what I know. I cut this log, but it's still the same length if I put the pieces together. So it's x plus 5x plus 7 plus x, and that's got to equal 84. Here we go, 5, 6, 7 x's plus 7 equals 84. Subtract 7. 7x equals 77. Divide by 7. Oh, that's nice and easy. 11 feet. What is 11 feet? 11 feet is the first piece. The second piece is 5 times 11, or 55 feet. Not inches, feet, 1 dinghy for feet. The last piece, 7 plus 11, or 18 feet. If I did this right, almost all of these checks can be done in your head. If I did this right, it will follow the words. Here, ready? First thing we have to know is it adds up to 84. 55 and 11 is 66. 76, if I add 10 more and 8, is 84. So there's your 84. And then let's read all the parts. It says it's cut into 3 pieces so that the second piece is 5 times as long as the first. This is 5 times as long as the first. And the next thing it said, if you remember, is that the first piece is 7 more. The first piece, well, let's read that again. The first piece is 7 less. I'm sorry. The first piece is 7 less than the third. So the first piece is 7 less than this, and the first piece is 7 less than this. So it represents all the pieces, and everything checks out. So first piece 11, second piece 55, third piece 18, and you're done. All right, let's look at this last problem. Carolyn, Lori, and Becky swim at a pool every day. One day, Carolyn swam twice as many laps as Lori, and Lori swam 3 laps less than Becky. If they swam 23 laps altogether, how many laps did each one swim? All right, here we go. Carolyn, Lori, and Becky swim at a pool every day. One day, Carolyn swam twice as many laps as Lori. Okay, here we go. Carolyn swam twice as many laps as Lori. Stop reading right there. If you can see, you know. All right. Carolyn swam twice as many laps as Lori. Of those two, we know nothing about Lori. So Lori is X. Carolyn swam twice as many laps than Lori. So Carolyn is 2X. Now, to be easy, this next sentence has to be about Becky. If it's not about Becky, we have to make it about Becky. So here we go. Oh, look at this. It says Lori swam 3 laps less than Becky. So let's write that down. Lori swam 3 laps less than Becky. Okay, the problem is we don't want Lori, we want Becky. So this is another example like the one we just did where we're going to have to rewrite this. So this is going to be if Lori swam 3 laps less than Becky, then Becky swam 3 laps more than Lori. Make sure you understand why we have to rewrite it. We want Becky, okay? So we wanted to start with Becky swam. Lori swam 3 laps less than Becky, so that means Becky swam more. So 3 laps more than Lori. So 3 laps more than Lori. So there's Becky, 3 laps more than Lori. Okay, so that's what we know. And now we're going to be able to solve the problem. So let's set up an equation. Okay, we know that Carolyn, Lori, and Becky all together swam 23 laps. I could still smell the chlorine, almost like I was there. Okay, so Carolyn is 2x, Lori is x, Becky is 3 plus x, and that equals 23. Now solving this, get all our x's together, 1x, 2x, 3x. Oops, sorry, that's 2x's. 2x, 3x, 4x, apologize. 4x plus 3 equals 23. You see this is going to come out nice. Okay, now we're going to subtract 3 from both sides. 4x equals 20. Divide by 4, divide by 4, x equals 5. This is 5 laps. Who swam 5 laps? Let's get back over here. Lori swam 5 laps. Carolyn swam 2 times 5, or 10 laps. And Becky swam 3 plus 5, or 8 laps. Now again, let's think about the check. Now, you know, I didn't say this before, but I want to say it now. This is not the only way to set up the problem, but it's the only answer to the problem. The answer is 10 for Carolyn, 5 for Lori, and 8 for Becky. Because this is the only, once we check it, if it checks out, this is the only thing that's going to check everything about the problem. So, first of all, we know it's 23. So 8 plus 5 is 13, plus 10 is 23. That takes care of the 23 laps. Then it said, Carolyn swam twice as many than Lori. Carolyn, twice as many than Lori, and 10 is twice as many as 5. And the very last one says, Lori swam 3 less than Becky. Lori is 3 less than Becky. Lori is 3 less than Becky. It checks out. So this is the only answer to this problem, but not the only way to set up the key and to solve the problem. And that takes care of lesson 3. I need a towel.